Next, we'll look at an example involving distance, speed, and time, and we'll use this formula. Average speed is distance over time. And here's the example. Joe drives 70 miles in 2.5 hours. What is his average speed? Well, the average speed, will be distance over time, so that will be 70 divided by 2.5. And the 70 is in miles, and the 2.5 is in hours, so the speed will end up being in miles per hour. Now let's write this in a way that's a little easier to work with. 70 is okay, I'll leave that in the numerator, but down here in the denominator, 2.5, let's write that as a mixed number, or let's change it from a mixed number to an improper fraction. So I do 2 times 2 is 4 plus 1 is 5 over 2. So 2.5 is the same thing as 5 halves. So I have 70 divided by 5 halves. And remember that dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. So instead of having 70 divided by 5 halves, I can write 70 times 2/5. And it's easy to see if you think of that 70 as 70 over 1. Realize that the 70 and the 2 are in the numerator, so we can multiply our numerators together, 70 times 2. But before we do that, let's reduce this. I notice here that the 70 and the 5 are both divisible by 5. So let's do that. 70 divided by 5, I'll work that out. 70 divided by 5, 5 goes in one time, so I write it there. I get 2 and bring down the 0, and 5 goes into 24 times. So that reduces to 14, and that reduces to a 1. So multiplying the numerators here is 14 times 2 gives me 28, and the denominators here now, it's just 1 times 1. So 28 over 1. And remember, this was miles, 70 miles in 2.5 hours. So the answer is 28 miles in the numerator and hours in the denominator, 28 miles per hour. If you go 70 miles in 2.5 hours, you're driving at an average speed of 28 miles per hour. This example involves division. We're told that Mary has 8.5 yards of fabric, and she needs 1 3/4 yards to make a child's dress. How many dresses can she make from the 8.5 yards? Well, I need to take the 8.5 and divide it by the 1 3/4. And as usual, this will be easier if we convert the mixed numbers to improper fractions. So we'll do the 8.5 first. 8 times 2 is 16, plus 1 is 17. So that's the same as 17 halves. And that's divided by this, 1 3/4. So this is 4 times 1, which is 4, plus 3, which is 7. That's 7 over 4. So I have 17 halves divided by 7/4. So I have this divided by a fraction. And dividing by a fraction is the same as multiplying by the reciprocal of the fraction. So instead of 17 halves divided by 7/4, I can write 17 halves times 4 over 7. And I notice here the 2 and the 4 can be reduced. Let's divide each of those by 2. So this becomes a 2 and that becomes a 1. And then we multiply here. 17 times 2 in the numerator is 34 over, in the denominator we have 7 times 1. So 34 over 7 is my answer. But no one's going to make 34/7 dresses. This is what we're trying to find out, how many dresses. So let's figure out what this is. 34 divided by 7. We'll work out the division here. 7 will go into 34 4 times. So 4 times 7 is 28. I subtract, I get a remainder of 6. So it's 4 6/7 is the answer. That's how many dresses could be made from this fabric. But nobody in the real world, nobody's going to actually make 6/7 of a piece of clothing. So you're just going to make 4, and then you have 6/7 left over. You have enough left over to make 6/7 of a dress. So you have some scrap left over that's not really usable for that, for making another dress. So the answer here is 4. 4 dresses. So we see that in this case it makes sense to truncate our answer. We just lop off the fractional part because it makes sense to give our answer as an integer or a whole number, just because of the nature of this particular problem.